In the German Forum DOSForum, the user Vesa Local Bus asked a curious question. He had a problem with, unsurprisingly, a Vesa Local Bus board, this Gigabyte GA-486VF. He wrote, "Whenever I type a colon, the system crashes." It turned out the problem goes much deeper, and it's not the system that crashes, it's the keyboard. So obviously, the board sends some data garbage to the keyboard, which then crashes. I wanted to find out what kind of data garbage this is, using my RetroARDUInput and its debug outputs. In the meantime, the board is fully repaired, with some interesting findings. Among others, that this board already made YouTube Carrier on the channel Necroware. Such repairs for third parties are called Fix My PC here in the German region, driven by Zenchili or Technikkeller, and internationally Fix or Flop, driven by Greg Salazar. So join me on this first episode of Retro Fix or Flop. Let's try to reproduce the problem. For the keyboard, I opted for a Cherry G80-1000 with a tandem branding. The compact flash card with the PC-DOS7 installation comes directly from the owner, so we have exactly the same environment as he did. Also, we have the German keyboard driver loaded to run under the same preconditions. And here we already see for the first time that pressing the Shift key has crashed the keyboard. Unplugging and replugging can resurrect it. And yes, I know that AT and PS2 are no hot plug capable interfaces. However, when I did this, I never ran into some issues. And as this is part of the diagnostics and also the owner did this, let's do it also. Pressing the numlock key doesn't change anything about the LED and crashes the keyboard again. However, this time, unplugging and replugging doesn't bring it back to life. As this result is even worse than what the owner described, I decided to change the keyboard. Now we are running on a Cherry G81-3000, and yes, it came in this design, except I swapped the green LEDs for blue ones at a certain time. And again, we have to unplug and replug it as we crashed it with the Shift key. And now be prepared for an oddity that the owner also described. The numlock key obviously activates the caps lock LED. And again, our keyboard has crashed. Unplug and replug it, and again watch some random behavior. Pressing the F5 key during boot up skips configsys and auto-exit bat. So we now don't have a keyboard driver and so a US keyboard, and everything works. And how does it look in Windows 95 with the German keyboard driver? Well, obviously the same error. Also here, unplugging and replugging brings the keyboard back to life. And to not skip any operating system, I'm now using one of my CF cards with DOS 622. And well, you guessed it. To understand what's going on here, we have to learn how the bidirectional communication of an AT keyboard is working. If you press a key, a make code is sent. For the letter A, for example, hex 1C. Once releasing a key, a break code is sent, consisting of hex F0 and the make code of the key. If you press one of the lock keys, the computer will send a new status of all LEDs. This consists of the command hex ED and the status of the LEDs. Caps lock is a special one. On the US layout, it's a toggle. Press once to activate, press another time to deactivate. On a German keyboard, however, it resembles an old mechanical typewriter. Here you lock by pressing caps lock and release by pressing the shift key. Pressing caps lock another time will not toggle. And as not only the lock keys but also the shift key has an influence on the LEDs, I think here we have our explanation why the shift key is able to crash the keyboard. Time to bring out the RetroARDUInput. At least nothing is crashing here, all keys react. The LEDs do something, although it sometimes doesn't fit the behavior. In the end it works, but it's far from perfect. Just have a look yourself. Let's have a look at the serial debug messages from the RetroARDUInput. Now I also understand why the LEDs react, but sometimes don't match the behavior. USB keyboards have both LED set commands and LED auto toggle. And the LEDs are simply toggled by the keyboard, as it doesn't receive any set command. Here you see the result enlarged. You see a lot of keystrokes, but no set commands coming from the host. And without AT set commands from the host, the RetroARDUInput cannot set the LED status via USB. To show how it should look like, I brought another mainboard out. My Biostar MB14-33-40-50 which by the way has such a cool AMI WIN BIOS. Has nothing to do with the topic, but I like it. And if you look at the debug messages now, you see how it should look like. Any press of one of the lock keys, and on the German keyboard also shift, will trigger a host to device command for set LEDs. Responsible for this problem could be the BIOS, the Intel 8042 compatible keyboard controller. In our case, it's an AMI Key 2. Or as we can see in this schematic, a 74 LS06 logic chip, which inverts and buffers the signal from the controller to the keyboard. It could be that guy here, but we come to this topic later. So first test, let's swap out the AMI key. Fortunately, the owner of the board already got a spare chip and sent it alongside with the mainboard. And did something change?
Computer says no.
To keep any results as reproducible as possible, I swap back the keyboard controller. In the next step, let's focus on the BIOS chip. First, I need to peel off the label to see which chip type we have. A 27C512 from Texas Instruments. Let's have a look at the RetroWeb for a new BIOS. The picture matches, this is our board. In the download section, you will only find one BIOS image. This has an older version number than the one installed. So before doing anything else, let's dump the BIOS first. Now it's the time that we need our chip type. Let's remember 27C512 from Texas Instruments. So let's drop the chip into our TL866 and hit the read button. But first, I want to check something else. Besides of the GA-486VF, Victor Foxtrot, there's also a 486VS, Victor Sierra. These two boards are practically identical except for the RAM slots. So let's have a look what BIOS versions we find here. And among others, we also find the version that was previously installed on this board. So let's compare this using the hex editor HXD and find out the two files are identical. Turns out later the two boards share the same BIOS. But for now, let's downgrade to the old version found on the RetroWeb. As this is still an EEPROM, not an EEPROM, we need to erase the chip with UV light first. This can take some time.
One eternity later.
The erasing process should be done now. But first, let's read the chip to check if everything is deleted properly. Otherwise, there could be problems while programming. For old EEPROM modules, you might need to uncheck the check ID mark. Otherwise, you might get an error message and the programmer will not start. The BIOS ID code matches the programmed version. But obviously, we still have the same problems as before. Now let's have a look at the inverter I mentioned before. But as the suspected chip on the Gigabyte board is a 7404 and not a 7406, we first have a look on the board from my collection, an MSI 4144. Here the 7406 is located between the second and the third ISA slot and shows exactly the behavior we expect from the schematics. However, on the Gigabyte board, the 7404, which is also an inverter, is in no means connected to the keyboard port. Here, the pins for data and clock input and output are both directly tied to the keyboard port without a buffer or inverter in between. So I started looking on some pictures of the mainboard in the internet. But no matter where I look, it's always a lens LT38C41. sometimes the large version and sometimes the small L version. Except for one picture, this showed an NEC chip. But in the end, the keyboard controller is only a microcontroller. The secret source is the code that's running on it. And maybe this code is not compatible to our mainboard. So I headed over to the German Forum DOSReloaded, where YouTuber Necroware is also active. He was facing similar issues with the keyboard controller in one of his videos, but I didn't find it anymore, so I asked him which one. He posted a link to the video and also offered to send me some replacement keyboard controllers for testing. Let's hear what the issues were that he faced.
As I looked at the socket for the controller once again, I noticed this soldered jumper JP32, which clearly says keyboard clock 14.3 MHz or some AT clock. The jumper was obviously hard set to AT clock. And if I think about it for more than 3 seconds, I realize that the issues I observed previously could have something to do with the wrong clock.
What's important here? The controller he was swapping was a lens. In his video, this controller was located on a Gigabyte GA-486VF, exactly the board that I just have here. And as he also repaired a broken trace below of one of the cache sockets, he asked me if I can find this repair also on this board. And if it cannot get funny enough in this video already, here's the repaired spot on the board that I have on my table. So this board already made YouTube carrier on the channel Necroware. When Necroware repaired the board, he surely tested the keyboard controller. In this snippet from his video, you will see that he tested in the BIOS, but he also tested in DOS with the German keyboard driver. All very strange, but let's wait for the chips he sends.
3 days later.
And here they are. The MB300E is a little bit different, maybe this works. During the test I will mark all chips with an N for non-inverted or for an I for inverted if they behave differently. Okay, so far all chips behave the same, except the MB300E, which went completely bonkers. I assume that this runs on the AT clock and not on the higher clock, so I need to revert the change that Necroware did to this board before. As you can see, no matter which key I press, the LEDs are all over the place. And to avoid the necessity to always have to change the jumper wire, I'm installing a 3-pin jumper header here instead. So the clock can always be changed by setting the jumper bridge. And yes, I have soldering skills, but I definitely have to train my skills soldering in front of a camera, not hiding what I'm doing. Job done, here's the MB300E with the freshly installed jumper. Quite a tight fit. Unfortunately, this chip uses the same clock as the lens, but behaves the same as the others. It doesn't work. But if we require an inverter, can't we just put one in between? Surely we can, and the solution can look something like this. Will this work? I have no idea, but there's only one way to find out.
So much later that the old narrator got tired of waiting and they had to hire a new one.
So let's try it. Here are the PCBs from China. We have to solder one SMD part. Let's start adding some flux to the pads. Then put a proper amount of solder on the pads. And finally, with enough flux and solder applied, I'm soldering the chip using hot air. When you are building such socket-in-socket solutions, it's always a good idea to use such precision pin headers. Such thicker pin headers as used with the Arduino might damage the socket or do not fit in it at all. To have everything properly aligned, we first put the pin headers into the socket and then put the PCB on top. Now we can remove our helper socket. The excess flux on this side of the PCB I removed off camera. Now we can insert the socket for the keyboard controller and solder it from the other side. And here it is. Doesn't it look nice? Yes, it doesn't look nice. So let's remove the keyboard controller and set the clock to the value for the ARMY key. And that's what I anticipated. A little too large is also too large. The solution for the moment, let's use a socket stack. So the PCB can float above the ISA slot and doesn't interfere with it. So let's insert the ARMY key controller and see that it's properly seated. Okay, this made the situation even worse. The keyboard doesn't react at all. Did I forget something? The capacitors and inductors should be already contained on the board to eliminate some interference. But obviously, I forgot some pull-up resistors. Yeah, what shall I say? Looks funny and doesn't work. And here would be the point where I would normally have given up, saying I know what it is, but I can't fix it as I don't have the spare part. But out of the sudden, two DOSReloaded users, I440BX and Giuliano XT, found some lens controllers in their spare parts. So let's start all over, now with the controllers that Giuliano XT sent me. And here they are, the two chips that Giuliano XT sent me. On the one hand, we have a lens LT38C41, the chip that belongs on this mainboard. So this should work, right? The other one is from a brand called Regional. I never heard of it before. The part number HD6542 sounds a little bit like Holtec to me. And a little bit of Google confirms this should be a Holtec. The lens requires the 80 clock, so we change the jumper again. And in it goes, our solution, likely the LT3841. First, let's enter the BIOS. Here we check the basic functionality. The normal keys are already reacting properly, a very good sign. Now we come to the numlock test. This is already misbehaving in the BIOS, so it seems the situation got even worse. So out with the lens and in with the regional/Holtec controller. Maybe this works. In the BIOS, everything looks quite normal. The basic keys are working properly. Also the lock keys are doing what they should. So good start. But as we remember, things became critical when the German keyboard driver was loaded. So let's boot the operating system. And also here, things look quite good. I think the board is working again. But I thought, before I judge too quickly, I will try another keyboard. So let's see if the Cherry G80 can confirm our hope. When testing thoroughly, this looks still a little bit odd. So let's do another test and run check it. Let's see how the keyboard LEDs react there. And this looks particularly okay, except of the scroll lock LED, which does not light up when it should. Let's try changing the clock again. Maybe this improves the situation. And this looks much better now. And also in Check It, all three LEDs are lighting up when they should. But there's one more thing I want to try. How does the lens controller behave with the other clock? And believe it or not, this worked perfectly in another test off camera. Now we seem to have some slight issues. The lock LEDs are not always switching. But now there's another thing I want to test. Now that we have a working keyboard controller, the regional, does the RetroARDUInput also work? And what already makes me quite nervous is that we don't have any keyboard handshake on keyboard reset commands during boot up. My assumption is that there is a slight design flaw in the RetroARDUInput, which leads to such problems with the rare design of this board. As you can see, all key presses are registered properly, but we don't get any handshake on setting the keyboard LEDs. Depending on how long the board is still with me, I will test a little bit. Maybe I'll require some pull up or pull down resistors in the design. As a final test, I want to run the CF card from the owner of the board with PC-DOS 7 and Windows 95. While doing so, it's time to draw a little conclusion. The misbehavior of the RetroARDUInput and the missing of the inverter could be misleading facts. In the end, I assume it was still a timing issue, and some keyboards are more prone to fail on bad timings. This could also be the reason why everything worked at Necroware. He used a more modern Cherry G80-1000, and it could be that this keyboard controller used in this keyboard is more tolerant against timing issues from the mainboard keyboard controller. And also, I want to say something about this format. It was very challenging, much fun, but also extremely time consuming. And as I don't have too much time, otherwise I would post videos more regularly on this channel, I would like to ask you to refrain to send repair requests to me just randomly. But if I find strange issues in forums like DOSForum or DOSReloaded, and I know that I can help, I will not hesitate to take over. So finally, this looks like a happy end for the user Vesa Local Bus and his Vesa Local Bus board, the Gigabyte GA-486VF. Just write in the comments, do you like such diagnostics and repair videos? If yes, also consider hitting the like button. And to not miss more of such content, especially as it comes in such irregular intervals, also consider subscribing the channel. I hope you enjoyed it and see you next time.